Greetings, Internet scientists have finally demonstrated that the universe is not locally real and that everything is an illusion. We are likely facing a shift in trends and a new development in physics. Science continues to advance by leaps and bounds. What was once considered magic, scientific philosophy, or the hypotheses of crazy dreamers is now official. Scientists Alain Aspect, John F. Clauser, and Anton Zeilinger have been awarded the 2022 Nobel Prize in Physics for their discoveries on the power of quantum mechanics, specifically on quantum information of entangled particles. This has paved the way for new technologies in quantum computing, artificial intelligence, ultralight communications, quantum sensors, precise measurements, and even gravity in space. Quantum physics explains the subatomic world, and everything is based on probabilities, even though it may seem to contradict logic. No matter how precise our measuring instruments are, we can never know the fixed value of a variable. This is known as the principle of uncertainty. The fact that the world functions through random, non-deterministic variables was unacceptable to Albert Einstein, and he made efforts to discredit this hypothesis. He believed there must be a flaw because if we live in a universe that can be explained by mathematics, there must exist hidden variables. Knowing these variables would eliminate the uncertainty. Einstein understood that quantum theory was incomplete and couldn't explain reality. If it were true, it would mean that everything is a product of chance, that the universe at its fundamental level would be inexplicable and truly indeterminate. For a physicist, this is a significant blow. What does quantum mechanics, which made Einstein and many other physicists so nervous, consist of? In physics, we understand something is real when an object's properties remain constant and stable and can only be modified by external variables, which cannot exceed the speed of light. Objects have defined properties independent of observation. So, when we say we live in a local universe, it means that the objects contained within it can only be influenced by their environment. For example, an apple will always be red, even if no one sees it, and any changes will be due to external factors. Classical physics is more intuitive, where everything is linear, predictable, with constant and calculable variables. In quantum mechanics, the properties of objects depend on the observer. We cannot know the exact value of particle properties unless we measure them. It is only when the measurement is made that the system collapses and the properties acquire a determined value. It's as if the observer creates reality in each moment. At a nanoscopic level, the atoms of the apple would be ordered, but at a subatomic level, everything would be random, even if we don't perceive it. That apple could become something else without external factors affecting it, but it could require a long time. But since Einstein, we have developed many laboratory experiments and verified that the observer determines the properties of a measurement and that particles can communicate with each other instantaneously, even if they are separated by thousands of light years. This is known as quantum entanglement, which is like telepathy between two particles in quantum mechanics. If two particles have interacted with each other and then become separated, whatever one particle does will still affect the other. If one starts spinning in one direction, the other will do the same. Obviously, this violated the theory of relativity because it would be considered that information travels from one particle to another at a speed faster than light, something Albert Einstein called spooky action at a distance and tried to discredit with all his might. Thanks to John Bell's experiments in the 1960s and subsequently updated, we have understood, even though it may seem incredible, that everything is interconnected, and therefore, matter and locality are illusions. We are creating new concepts that are now grounded in teleportation and quantum computers. Entanglement, and now here comes something that will blow your mind. The Einstein-Podolsky-Rosen paradox, or the EPR paradox, was a thought experiment proposed by Albert Einstein, Boris Podolsky, and Nathan Rosen in 1935 to demonstrate the absurdity of quantum mechanics. To understand the EPR paradox, we must remember that in quantum mechanics, we cannot know the properties of particles unless we measure them, and they only acquire a determined value upon measurement. Now, let's imagine that we send two entangled particles to two very distant locations, and we want to know if they spin to the right or to the left without measuring them. Quantum mechanics tells us that their properties will be in a superposition of states, both left and right at the same time. But if we measure one of them, we will instantly know the spin of the other. That's the dilemma Einstein thought about. How is it possible for us to know the spin direction of the other particle without measuring it? That would violate the principle of quantum mechanics and create a paradox. If this happens, it means that the particles do have predetermined properties. Therefore, Therefore, quantum mechanics must be incomplete. Einstein considered two assumptions obvious. The first one tells us that a car travels at 100 kilometers per hour, whether or not it has a speedometer, and the second one is locality. There is no way to influence something or someone far away unless we send them a signal, and that signal must travel at a maximum speed equal to the speed of light. If these two assumptions are true, quantum theory enters an enormous paradox. Niels Bohr reached a conclusion that there is no such paradox because we are in a non-local and non-realistic universe. When we measure one particle, we exclude the possibility of measuring the other. In 1960, an Irish physicist named John Bell realized that Einstein, Podolsky, and Rosen had not discovered a paradox but something much greater in our understanding of the universe. There must be a method to measure quantum particles. That's when he created his famous Bell's theorem of inequalities. There must be certain hidden variables that allow us to discern experimental observations and that each particle has predefined properties. Experiments have shown that Bell's inequalities are experimentally violated. There are no hidden variables. We are in a non-deterministic universe. Entangled particles appear to be connected as if they form a single system, and space does not exist for them. Furthermore, relativity and quantum mechanics complement each other. If we measure a particle, there will be a 50% chance of obtaining a left or right rotation axis, and there is no way to transmit information to the other particle by manipulating its rotation axis. This demonstrates that geniuses like Albert Einstein can open doors to knowledge, but, at the same time, close themselves off to other alternatives and risk their ideas. Interestingly, Einstein received the Nobel Prize not for his theory of relativity but for the photoelectric effect, a quantum phenomenon. In 1982, Alain Aspect conducted a rigorous and irrefutable experiment involving entangled optical photons and changed the measurement settings after the entangled pair had left its source. The initial configuration did not affect the result, and there were no hidden variables. This experiment earned him the Nobel Prize and allowed him to demonstrate the quantum theory. It has also made us consider something truly fascinating. Every time we observe or obtain a result, a different branch is created in a universe. The existence of superposed quantum states is known as Hugh Everett's interpretation. Every time we measure a result, a universe is created. Therefore, all results are physically possible locally and separately in countless branches of the universe. Do you remember a moment in your life when you were on the verge of making a decision or miraculously saved your life? In another universe, you would be dead, but in this one, you continue to exist. In the end, your existence prevails to give meaning to all of this. It's something that can blow one's mind, but it's compatible with Alain Aspect's results. The EPR paradox would only occur due to our inability to perceive those universes locally. Every time you make a decision, multiple realities are created where you made other choices, and this could even lead to the very beginning of the universe and other multiverses. Imagine the void filled with quantum fluctuations where time doesn't exist and states are randomly in superposition until consciousness arises and the state collapses. We create the universe, time, and everything else. It is us who decide through observation which universe to live in. John F. Clauser, on his part, has also demonstrated experimentally that there are limitations to the concept of locality, and Bell's inequalities are violated through polarized photons. Once again, it was confirmed that particles do not have intrinsic properties when emitted. Anton Zeilinger, in the 1990s, managed to teleport two photons from one bank to the other of the Danube River using two machines called Alice and Bob. Quantum teleportation through independent qubits has allowed practical development of quantum computing decades later. These great advances allow us to definitively access a new physics. What we call real is just a point of view. We see the universe from a single state among the many possible ones. We are in a strange world, and what we perceive as logical is only an illusion, information created by our minds so that we can understand it. If quantum mechanics doesn't impact you, it means you don't understand it. A new scientific truth doesn't triumph by opening the eyes of your adversaries, but because your adversaries die, and a new generation takes over. We must understand that the quantum world follows different laws than the ones we know. The object is not separate from the observer. Everything is connected. Objects must be analyzed as a whole, not by their properties. Descartes, I think, therefore I am, has led us for many centuries to an extreme rationalization of everything, where humans were independent from the world, and what we saw were absolute truths in a deterministic cosmos. It is not a belief or a hypothesis. The Nobel Prize in Physics was awarded to 3 scientists who discovered that the universe is not locally real. This means that objects do not have independent properties from observation. Our universe was born from quantum fluctuations and created our macroscopic world. But if we live in an interconnected holistic universe, everything is a relative local illusion to the observer. There is also another incredible possibility. We might still be a quantum fluctuation that has become conscious in its complexity and has created an impossible universe full of paradoxes and entangled states. We are increasingly confused, but fascinated, opening doors to the unknown. You know the drill. If you liked the video, give it a like and subscribe, share it on social media, and leave your comments.